So, good day everyone, and today we have three topics to discuss, which is the length of the curve, surface area, and the centroids. And each one I will give you one or two examples or more than examples for each. And the learning objectives is we can solve each equation for each topics. So, first in the length of the area. I will give here an example of find the curve of y is equals to 1/3 x squared plus 2 3/2 x is equals to 0 to x is equals to 3. So we have a graph here. And this one here is the A. This one right here is the B. So we have to find the length of the curve. So we have to do is dy over dx equals to 1/3 times 3/2 parenthesis. This is 1 of 2x. This we will cancel out. So we have here x plus times x squared plus 2 1/2. And we have here again the dy over dx squared, which equals to x squared times x squared plus 2. This equals to x raised to 4 plus 2x squared. And now we're gonna have to find the line. Our upper limit is 3 and lower limit is 0. And our given is 1 plus 2x squared dx is equals to x raised to 4 plus 2x squared plus 1 dx equals 3 0 x squared plus 1 raised to 2 dx, and we're just gonna simplify x squared plus 1 dx equals x plus x is equals to 27 over 3 plus 3 minus 0 plus 0. And now we're just gonna compute it in our calculator. Which is equal to 12. Here is the calculator, and that's how you're gonna find in the example number 1. And now we're gonna proceed to example number 2. Our example number 2 is we have here the y is equals to 6x plus 3, and our x is equals to 1 2 x equals to 7, and our graph for that is just like this. This 1, here is 7. It's gonna move straight line. Here is our 1 7 A B. And to solve for that, you have to find L again, the length, because this is the topic for the finding of length of the area. So B rather than length of the curve, I mean, sorry. Radical 1 plus dy dx squared y is equals to 6x plus 3. Now we're gonna use again the dy dx method. So 6 squared, and we're gonna put that to which is equals to 36, right? And now I'm just gonna proceed 7 over limit and over limit 1 plus 36 dx square root of 3 plus 7 minus 1 is equals to, we're just gonna get again in our calculator. Which we have 6 that's how you get your final answer. Oh, sorry, this is 3 only. And that's how you get your final answer for the length of the curve. And for the next topic is the surface area, and I will give you an example for that also. So now we will start our topic in the surface area. So first example, so I'm gonna give you a first example, which is 3x plus 2y plus z is equals to 6, that lies in the first quadrant. So what you're gonna do first? First we will locate the graph. This is the 3, 2, verse 12. Let's say these are 22. These are graph. Now our y here is we have here our z, which is 6 minus 3x minus 2y, and f of x is still negative 3, and the other one is 2. This is our limits. And for our limits, we have 0 less than plus 2 plus 3. Now we're just gonna look for the surface area. Now we're just gonna have to solve. So double integral d 3 raised to 2 plus negative 2 raised to 2 plus dA equals our upper limit is 0 to lower limit is 0. The other one is negative 3/2 plus 3, lower limit is 0. 14 dy dx equals to square root of 14, 0 minus 3 halves, x plus 3 dx. So square root of 14, get 3/4 x squared plus 3x to 0. And now we're just gonna use our calculator to solve for the final answer. And the final answer is 3 and square root of 14. Now let's proceed to our example number 2. For our example number 2, let's say let f of x is equals to square root of x, x is equals to 1, 2, x is equals to 4, revolving the graph f of x around the axis. And we have a graph here. This is f of x equals square root of x. And here a cone-like shape for f of x is equals to square root of x. First derivative is equals to 1. X is equals to, sorry, it's a parenthesis. So now we're gonna look for the surface area. And here we have a 2 pi f of x square root of 1 plus, this is f of x 2 dx. Let's do upper limit is 4 here, lower limit is 1 here. 2 pi square root of x, which is the f of x, 1 plus 1 over x dx is equals to 4, 1, 2 pi x plus 1/4 dx. And here we're gonna use our u substitution. U is equals to x plus 1/4 du dx. X is equals to 1, is equals to 5/4, then x is equals to 4, and u is equals to 17/4. Well, this is for our limits for the next 0, 2 pi square root of x plus 1/4 dx is equals to 7. Oh no, it's a simplified form. 5/4 2 pi u du is equals to 2 pi 2/3 2 equals to pi sixth 17 minus 5 square root of 5. Now we're gonna use our calculator to solve for the answer. Which is 30.846, and that's your final answer for the problem number 2. And for the next topic, we will proceed to centroids. So hello, good day, and for today's topic we have here are centroids. And the first example is we have centroid of the areas under the curve y is equals to 2 sine x from x is equals to 0 to x is equals to pi. So we have a graph here. These are 0 kind of origin, and this we're gonna put our here the pi like that. Here are vertical strip. Here is our y dx, is dx, and this is the dx. For y dx is equals to pi, upper limit, lower limit 0, to x sine x dx over ry pi 0 to sine x dx is equals to pi over 2. That's how you get your x, and here you're gonna find our y dx is 2 integral of y dx, here I see dx over y dx pi 0 1/2 sine x raised to 2 dx over integral of upper limit pi, lower limit 0 to sine x dx equals our gonna compute for our final answer pi over 4, and that's how you get your y and your x. Now let's proceed to our problem number 2. For our problem number 2, this is much more complicated. Find the centroid of the area bounded by the curve y is equals to square root of x and y is equals to x squared. Now let's draw here our bar graph. Our graph, we're gonna do like here. These are y1 is also x squared and y sub 2 is equals to square root of x. And here inside is our vertical strip we put inside. X prime y1 is equals to 0.45. See, y2 minus y1 over 2. And here is E1, 1. That is the location of the points. y2 minus y1 divided by 2 is equals to AC. And the vertical strip here is our y2 minus y1 dx. And now we're gonna find for the x. A xc over a dot is equals to, the limit is 1 and 0, 1 over x, y sub 2 minus y sub 1, parenthesis dx is equals to 1, 0, y sub 2 minus y sub 1 dx is equals to the given, which is 0 x minus x squared dx over 0 parenthesis x minus x squared dx, which is 2 here, which is the 0.45. Now we're gonna look for y prime. Okay, minus, let's see, it's equals to y is equals to dx 2 plus y sub 1 over 2 and then over again equal of y sub 2 y sub 1 dx is equals to, what is the value of 1/2 x minus x raised to 4 dx over 1, 0 minus x squared dx, and our final answer is 0.45, the same as the x prime. And that's all. Thank you.